Good day everyone, we are from Group 9 and we are doing Hardness test, and our topic is Mechanical Properties and Failure Analysis Approach on Crankshaft. So I'm Sheyo and these are the rest of the members.
I'm Ito.
I'm Jonakil.
I'm Amira. I'm Atika.
And I'm Mama. Hello. So for crankshaft, we need high yield point. So as we know, yield strength or yield stress is the material property that defines as the stress at which a material begins to process or deform plastically, which yield point is the way the non-linear or the separate of the plastic and the elastic part. So in crankshaft, we need these types of properties as it undergoes many processes, and the crankshaft must not change its shape after the load is pulled. Okay, good elastic deformation. A temporary shape change that is self-reversing after the force is removed, so that the object returns to its original shape. As I said just now, the crankshaft must not change its shape when the object and when the force is removed from the object. Besides that, we must have the high ductility. The ductility is a solid material's ability to deform under tensile stress. So we must have the high ductility so that the crankshaft must not change its shape when the force is applied to them.
Okay. The mechanical properties of the crankshaft is one of the properties is corrosion resistant. Corrosion resistant is the ability of materials to resist oxidation at high temperatures in gaseous medium such as air or oxygen. Okay, crankshaft we use in many of the machine so that at many conditions and at many temperatures, so that we want the crankshaft to be tahan nasab to reduce the failure of the crankshaft. Furthermore, tensile strength is also one of the mechanical properties of the crankshaft. Tensile strength is a measurement of the force required to pull something such as rope, wire, or a structural beam to the point where it breaks. Why we need tensile strength to be one of our mechanical properties in the crankshaft? This is because we use crankshaft to pull something, or it will push and pull in the machine, so that we need the high strength of the crankshaft.
Next, the mechanical properties of the crankshaft is the insulator. An electrical insulator is a material whose internal electric charges do not flow freely. Very little electric current will flow through it under the influence of an electric field. For insulator, if the crankshaft is the conductive, it will give the harm to the conductor to conduct the machines. Lastly, the mechanical properties of the crankshaft is the wear resistance, a surface or material that does not easily damage by frictions or use. This wear resistance is important for the crankshaft for the long lifespan of the machine.
So these are the examples of crankshaft failure. So we can see the circle one, they are all cracked, either cracked or bent. So first of all, we have to carry out the failure analysis approach with which we have to investigate the problem why this failure occurred. So first of all, we have to ask ourselves, what is the reason that caused the problem to happen? So maybe it is over-pressurized, or the crankshaft itself has low hardness originally. And these two are the failure modes that may occur, which are bent or cracks. So all these failures will lead to the loss of operations or accidents on the user. So what can we do to fix this problem? Maybe, one of the ways is to carry out the hardness test. So which type of hardness test that we're going to use in order to fix this problem? It can be either Rockwell, Brinell, Vickers or Nook, but we have to depend on the specimen itself. For example, whether the type of surface is coarse or fine, or whether it is small or big.
The specimen that we choose is crankshaft, and that's why we use hardness, Rockwell hardness and Brinell hardness test to test the hardness of the specimen. There is the difference between Rockwell hardness and the Brinell hardness, which start from the Rockwell hardness. It can be tested on all metals, but there must be no difference in the surface variation. While for the Brinell hardness, it can test on the material with over, coarse or rough surfaces. For the indenter, Rockwell hardness has the indenter which depends on the test scale, while for Brinell hardness, the indenter is only one, which is ball indenter, but in in different diameter, 1 mm, 2.5 mm, and so on. While for the lot, there's a big difference. For Rockwell hardness, you can use 2 lots, which is minor with up to 10 kgf and major up to 150 kgf. While for Brinell hardness, there's only a single lot, which used from 1 kgf to 3000 kgf.
Okay, so this is the Rockwell hardness test. We have 2 types of machines. There is the analog machines and digital machines. And the machines we are currently using in our material lab is this, the digital machine for the Rockwell hardness test. So the first step in the Rockwell hardness test is that we have to select penetrator and test block. That is the crankshaft that we want to test. And then the next step is we have to set up the tester. So how do we do that? First, we need to select the right indenter for the specimen. For example, we have bore indenter, diamond indenter, etc., etc. And then we have to choose the correct one that can match with the specimen. So after we select the indenter, here comes the third step, which is we have to apply the minor load until the line mark set. That is, we turn this thing until the line mark set, until the set marks. And then if we overturn it and it is overload, we have to do it over again, like change the place of the specimen and then turn again until the line mark set. After that, the load will be applied on the specimen. That is, the indenture will go down on the specimen and indent a hole into the specimen. And then, after the indentation, we can take the reading for the Rockwell hardness test. So this is the Brinell hardness test. The first step is we have to select the indenture size. The difference between the Rockwell hardness and the Brinell hardness is that for Brinell hardness we only have bore indenture. So we need to select the correct bore diameter for the specimen. And then the next step is that we have to set up the test load that is suitable for the specimen. It cannot be too heavy or cannot be too light. And then we apply the load on the specimen. And then after we apply the load, we can measure the indentation diameter. And then the difference between this is that we have to calculate the Brinell hardness by applying this formula, which is different from Rockwell hardness, that we can get the hardness number directly. So we have to calculate it using this formula. F is for the load, and then the alphabet D is for the bore diameter, and then the small d is for the indentation diameter. And then after applying this formula, we can get the Brinell hardness number for our specimen. So this is the example for the hardness test graph. This is the graph for the Rockwell hardness test, and that one is graph for Brinell hardness test. So this is the result that we get from the analysis of our failure approach. Thank you.
So yeah, that's all from us. Thank you.
Thank you.
Thank you.
Thank you.
Macam mana nak clap?
Clap.
Okay.